Good morning, this is Miss Yu, and today I'm gonna complete the chapter 2.2 Graphing Linear Equations notes together with you. So let's quickly review how can we calculate the slope. Slope is rise over run, which is also changing y over changing x. Changing y is y2 minus y1. Changing x is x2 minus x1. But the direction you subtract points in the slope formula doesn't matter as long as you are consistent for both the y and x coordinates. So you can also do y1 minus y2 over x1 minus x2. You're gonna get the same slope. So the direction doesn't matter. You can use this point minus that point, or you can use that point to minus this point. It doesn't matter. And let's see, we already finished the first page and we finished the second page. And we also finished the third page. So on the third page, the example 2, we have a special situation where we have a horizontal line. When we have a horizontal line, every point on this line, they're not going up or down. So there's no change in y. There's no vertical change. So the change in y is 0, which means rise over run, we have 0 on top. And 0 divided by any number is 0. So in this case, we have slope is 0. And on page 4, we have another special situation. We have a vertical line. On this vertical line, every point, they're not moving to the left or moving to the right. So there's no change in x, there's no horizontal change. So our rise over run will have 0 at the bottom. And we cannot divide any number by 0. So this one would be undefined. The slope would also be undefined. So for next 3 questions, we did the first one and the second one. So basically, we are doing the same thing. So when we have the graph, we just use 2 points. And here, we just don't have the graph. We only have the 2 points. But we're doing the same thing. We just find the slope, which is y1 over y2 over x1 minus x2. But of course, you can also do y2 minus y1 over x2 minus x1. So you can always do the inverse and it won't affect the answer. So let's see. If we do the first one, y1 minus y2. So 8 minus 0 over 0 minus 0. So we'll have 8 over 0. Since we have 0 as a denominator, the slope is undefined. So let's see if we do the inverse. If we do y2 minus y1, so now we'll have 0 minus 8 over x2 minus x1, which is 0 minus 0 again. So we'll have negative 8 over 0. Still, we have the 0 at the bottom, so the slope is also undefined. So either way, we'll always get the same answer. So that is that. Use the given points to find the slope of the line. And let's see number 7. How do you know that the slope of every horizontal line is 0? And how do you know that the slope of every vertical line is undefined. So if you remember, if you have a horizontal line, there is no change in y, okay? There is just horizontal change. The points are not going up or going down, which means our rise over run, since it's not going up or down, our changing y, or like the changing rise, is 0. It's not changing. It's not going up or down. And our run is just x2 minus x1, or you can also do x1 minus x2. So anyways, we'll have 0 on top, which means our answer is always 0. And this is our slope. So how do I know the slope of every horizontal line is 0? It's because my change in y is 0. And for our vertical line, if it's a vertical line, we don't have any change in x. It's not going to the left or going to the right, which means our rise over run, since it's not going to the left or right, our run, there's no change in x, so our run is 0. Our rise is y2 minus y1, or you can also do y1 minus y2. But either way, you have 0 as a denominator, which means your slope is undefined. So you can say it's because there's no change in x. Our change in x is 0. Changing x is 0, so we know that the vertical line, the slope of every vertical line is undefined because there's no change in x. So that's number 7, the two special situations for linear equations. And let's see example 4. Finding slope from a table. So table is another representation other than the graph. So let's see, the points in the table lie on a line. So they're all points on the same line. They're all points on the graph for the linear equation. How can you find the slope of the line from the table? And what is the slope? So let's see. The first row we have x, and the second row we have the y. So let's write out all the coordinates. The first one, we have xy, because our point, our ordered pair is x comma y, right? So we have x in the front, so 1, 8. That's our first point. Our second point, x comma y, we should have 4, 6. And our third point is 7, 4. Our fourth point is 10, 2. So now we have written out all the ordered pairs. And it says choose any 2 points from the table and use the slope formula. Okay, so let's do this. It says choose any 2 points. So what about I choose the first one and the second one? And I will choose another points to see if we can get the same slope. So if we choose this one, the first one, as my x1, y1, x2, y2. So my x1, y1 is 1, 8. x2, y2 is 4, 6. And our slope is rise over run, which is changing y. So let's do y2 minus y1. over x2 minus x1. So we should have y2 minus y1, which is 6 minus 8 over our x2 minus x1. So we'll have 4 minus 1. So 6 minus 8 is negative 2. 4 minus 1 is 3. So this is our slope, negative 2 over 3. And let's see, if we choose another 2 points, for example, if I want to choose the third one and the fourth one, and I want to use the inverse direction. So let's see, our slope would be, since I'm using the inverse direction, I can use y1 minus y2 over x1 minus x2. So in this case, so this is, I still choose this one as my x1, y1, and this is my x2, y2. So my y1 minus y2 would be 4 minus 2. So I have 4 minus 2 on top. And I have my x1 minus x2, so it would be 7 minus 10. So I'll have 2 over negative 3. And you'll find out, you get the same answer. Just remember, negative 2 over 3 is the same as 2 over negative 3. And it's the same as negative 2 over 3, okay? They're all the same thing. So it seems like if we choose any 2 points and then we use a slope formula, we can always get the same slope. And the direction doesn't matter, as long as you are consistent for both the y and x coordinates. So let's see, if we want to check using the graph. If you remember, in the first class of this chapter section, we find the slope by counting the boxes. And before we do that, we need to plot all the points. So let's see, the first point is 1, 8. We find 1 on the x-axis, and then we go up 8 units. This is our first point. The second point, we have our 4, 6, so find 4 on the x-axis, and then go up 6 units. The third point, we find 7 on the x-axis, and then we go up 4 units. The last point, we find 10 on x-axis, and then we go up 2 units. And then we connect all the 4 points. So this is our graph. So to use a graph to find the slope, again, we do the same thing. We just find any 2 points. For example, let me do the first point and then the third point. So if I do this direction from that point to the bottom point, I want to find the slope, which is rise over run, which is changing y over changing x. Changing y is like the vertical change. So from that point to this point, it's like going down, right? It's like going down 1, 2, 3, 4. It's like going down 4 units. So the rise is negative 4. And then for the run, it's like the horizontal change. So from that point, you need to go to the right. 1, 2, 3, 4, 5, 6. Since you're going to the right, it should be positive because it's getting bigger. You need to add a positive 6 to get to get there, to get to another point. And if you're going to the left, that would be the negative. And here, if you're going to the down, if you're going down, it's negative. If you're going up, it's positive. So let's see, we can simplify this. Since 4 and 6, they're both even numbers, you can divide them by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So you will have negative 2 over 3. And you get the same answer here. So let's try if we use another 2 points. If I want to use the second point and the last point, and I want to do the inverse direction. Now I want to go up. So from the bottom point to the second point. So my slope is rise over run. Rise is a change in y, it's a vertical change. So from that point to the second point, we need to go up. We go up 1, 2, 3, 4. We need to go up 4 units. So our rise is a positive 4. And from the bottom point to the second point, we need to go to the left. 1, 2, 3, 4, 5, 6. We need to go to the left 6 units. Since it's going to the left, it's getting smaller and smaller, so it would be negative. So again, we'll get negative 2 over 3. So as long as you use the rise over run, it doesn't matter which 2 points you choose, it doesn't matter which direction you use. You will always get the same slope. So the key points here is just rise over run. That's example 4. And I'll give you 1 minute to fix your answer. And let's see next one. We have 2 problems here. I want you to try on your own first, and then you can check your answer with me. So you may pause the video, and then when you're done, you can continue the video and check the answer with me. So it says, the points in the table lie on a line. How can you find the slope of the line from the table, and what is a slope? So we can pick any 2 points. For example, I want to pick the first point and the third point. So my slope would be rise over run, which is changing y. So let's do y2 minus y1 over x2 minus x1. So my x1, y1 is 1, 2, and my x2, y2 is 5, 8. So my y2 minus y1 would be 8 minus 2 over my x2 minus x1, which would be 5 minus 1. So it would be 6 over 4. And you simplify, you will get 3 over 2. That's problem 8. And let's see problem 9. Now I want to use the second and the fourth point. So let me do slope equal now I want to inverse the direction. I want to do y1 minus y2 over x1 minus x2. So my x1, y1 is negative 2, 4, while my x2, y2 is 0, 0. So my y1 minus y2 would be 4 minus 0. And my x1 minus x2 would be negative 2 minus 0. So let's see. 4 minus 0, that's still 4. Negative 2 minus 0 is still negative 2. And we simplify, we would get negative 2 as our solution. So that's our slope, negative 2. So that's problem 8 and problem 9. And then now we can summary. We have total of 4 situations. We have the positive slope, negative slope, when the slope is 0, and when the slope is undefined. So the positive slope, the line should rise from left to right. So when it's going from left to right, it's rising, so it's going that way. So let's draw. So it's going up from left to right. It could be there, it could also be here. Okay, it doesn't matter where it is, but as long as it's rising from left to right. And our negative slope, the line, remember it's also from left to right. So when it's negative, the line should fall from left to right. So which means when it's going from left to right, it's almost going down. It can also be here. It can also be here or there. And then let's see, when the slope is 0, the line should be horizontal, because if the slope is 0, that means we should have 0 on top, which means the change in y should be 0. It's not changing vertically, so it stays on a horizontal line. It could be here or there or down here. Okay. So that's a third situation. Then let's see the last one. When we have the undefined slope. When we have the undefined slope, which means our rise over run, we should have 0 at the bottom so that we can have the undefined slope. And the bottom one is a run, which means the change in x is 0. There is no change in x. It's not going to the left or right, okay? It's just all the points just stay on this vertical line. So the line is vertical. Any line like this, any vertical line, they all have the undefined slope. So that's a summary for the slope of linear equations. And for your assignments, I want you to do from problem 1 through problem 25. I'll go over some with you. So let's see the first one. It says, the first one, vocabulary and concept check. Critical thinking, refer to the graph. Which lines have positive slopes? Positive slopes, that means from left to right is going up. From left to right is going up. So we should have line B and line C. And which line has the steepest slope? If you remember, the slope represents the steepness of a line, okay? Which means the steeper a line is, the bigger the slope is. Okay, so let's see. We can also use any 2 points to find the slope, because we know the bigger the slope is, the steeper the line is, right? So let's see. The line B is flat, is obviously flatter than other two lines. So let's check for line C and line A. Line C, let's pick these 2 points. So for line C, our slope is rise over run. So let's see, from that point to the upper point, the rise would be 1, 2, 3, 3, and the run would be 1, 2, 3, 4. So my slope is 3 over 4. Let's see for line A. Let's pick those 2 points. So let me go up. So line A, the slope is rise over run, so it has to go up 1, 2, 3, 3 boxes. The run, it should be go to the left 2 boxes, so it's 3 over negative 2. It's going to the left, so it should be a negative 2. So we just need to see the 3 over 4 and 3 over 2. So to see which one is steeper, we just need to look at the absolute value of the slope. The absolute value is like the absolute value for 3 over 4 absolute value of a positive number, it's always itself, so it's still 3 over 4. While the absolute value for negative 3 over 2 should be a positive 3 over 2. And a positive 3 over 2, you can multiply by 2 on top and at the bottom. So you have 6 over 4. And you will see it's greater than 3 over 4, which means the absolute value of the slope for line A is greater than the absolute value of the slope for line C. If the slope is bigger for line A, that means it's steeper. So for question B, we should have line A. Line A has the steepest slope. Do any of the lines have undefined slope? If one line has undefined slope, that means it should have 0 at the bottom. That means the run is 0. That means there's no change in y. Okay, that means it should be a vertical line, but here we do not have any vertical line, so it's no. And I want you to do number 2, number 3 by yourselves. Let's see the problem 4 through problem 6. So it says, draw a line through each point using the given slope. What do you notice about the two lines? So we've already did the same thing in the previous lessons, right? So let me do the first one with you. The slope is 1. Slope is rise over 1. So if we start from the black point, that means we can go the rise over 1, which means rise over 1 is 1, so we can do 1 over 1. But you can also do 2 over 2, or 5 over 5, or -5 over -5, as long as the answer is 1. So if you do 1 over 1, that means you go from the black point and then you go up 1 unit. And then you go to the right 1 unit. And then you connect those 2 points. So if I use another point, and now I want to do, for example, I want to do -2 over -2. So that means I need to go down 2 units. And I go to the left 2 units. So I find another point. So you need to use a slope to find another point. As long as you have 2 points, you can connect those 2 points to find the graph for that linear equation. So let's connect those 2 points. And what do you notice about the 2 lines? So you should notice that they should be parallel to each other. You should, we did this in the first lessons in this chapter, I guess. And we talked about when the 2 lines, if they have the same slope, the 2 lines should be parallel to each other. So that's question 4. And let's see for question 5. If the slope is -3, so you can do -3 over 1, or you can do 3 over -1. So for example, if you start from the black point and our rise is -3, that means it's going down 3 units. 1, 2, 3. And our run is 1. It's a positive 1, so you go to the right 1 unit. And then you connect those 2 points. And then for the red point, I want to do 3 over -1. So rise is 3, so it has to go up 1, 2, 3 units. And then the run is -1, so it has to go to the left 1 unit. And then we connect the 2 points. And then you'll find they're also parallel to each other. And I want you to do number 6 by yourselves. And then let's look at number 7. I'll just do one problem and then you do the other 5. So number 7, we already have 2 points. So let's let this point to be x1, y1, and then that is x2, y2. I want to use my slope as y2 minus y1 over x2 minus x1. So my y2 minus y1, it would be 3 minus 0 over my x2 minus x1, that would be 2 minus negative 2. When you're using negative numbers, make sure you put a parenthesis for negative numbers. So 3 minus 0, it's still 3. 2 minus negative 2, if you have two negative next to each other, you can substitute those with a plus, so it becomes 2 plus 2. So it's 3 over 4. That is our slope. So for question 8 through 12, you're going to do it by yourselves. You simply use 2 points, and then you use the changing y over changing x. But just pay attention to the negative numbers. So that's 7 through 12. And then let's see the 13 through 18. It says find the slope of the line through the given points. I'll just do one and then you do the rest of those. So let's see number 13. I let the first one to be my x1, y1. The second one to be my x2, y2. So my slope is y2 minus y1 over x2 minus x1. My y2 is negative 1 minus y1 is negative 1. So negative 1 minus negative 1. My x2 minus x1 is negative 2 minus 4. So on top, it becomes negative 1 plus 1. The bottom, negative 2 minus 4 is negative 6. So I'll have 0 over negative 6, which is 0. So the slope for the first one is 0. You can also observe that for the first 2 points, they have the same y coordinate, which means they should be on the same horizontal line. So if you plot out those 2 points, you would have the first one is 4, negative 1. The second point is negative 2, negative 1. You'll see they're on the same horizontal line. So you can basically also just graph, and then you'll notice since it's a horizontal line, the slope should be 0. And for example, number 15, they have the same x coordinate. So if you graph out the points, you will see the first point is negative 7, 0. It's right here. The second point is negative 7, negative 6. So negative 7, negative 6 is right here. So you'll notice they have the same x coordinates. So they are on the same vertical line. So in this case, the slope should just be undefined. So you can use either way. You can use y2 minus y1 over x1 over x2 minus x1. Or sometimes you can just observe to see if they have the same x coordinate or if they have the same y coordinate. And we can graph out the points to see whether they're on the same vertical line or they're on the same horizontal line, so that you can identify the slope. Then let's see number 19. Number 19, it says error analysis, describe and correct the error in finding the slope of the line. So we have 2 points here, 2, 3, and 4, 1. It says the slope is 3 over 1, okay, 3 over 1 over 4 over 2. So first of all, we should be consistent for y coordinates and x coordinates, which means if you use 3 over 1, you're using the first point to minus the second point. So for the x coordinates, you must also use the first point minus the second point. So your slope should be 3 minus 1 over 2 minus 4 instead of 4 over 2, okay? So it should be 2 over negative 2, which is negative 1. And you can check because it's falling from left to right, so the slope must be a negative number here, negative 1. But here it has a positive 1, so it's definitely wrong. That's number 19. And let's see number 20. Critical thinking is it more difficult to walk up the ramp or the hill? That means we're looking for the steepness, okay, of the angle. So again, we just use a rise over run. So for the first one, our slope is rise over run, rise a vertical change, which is a positive, it's a 6, positive 6, over run, which is 8. So you can pretend you're going from the upper point to the down point, okay? And then the second one, the slope is rise over run. So it's 8 over 12. And when we simplify, we divide by 4, we get 2. Divide by 4, we get 3. So it's 2 over 3. Here, if we simplify, it should be, we divide by 2, that's 3. We divide by 2, that's 4. So we have 3 over 4. Actually, if you're going from the upper point to the lower point, it's going down. So the rise would be negative 6. And then it's going to the right, so it's positive 8. So it would be negative 3 over 4. And here, if we're still going from the upper point to the bottom point, we're going down 8 units. So it's negative 8. And then we're going to the left 12 units, so it's negative 12. And then we have negative 2 over negative 3. But when we're looking for the steepness, we just use the absolute value of the slope. So here the absolute value for negative 3 over 4 is a positive 3 over 4. While here the absolute value of negative 2 over, here negative 2 over negative 3, 2 negative becomes a positive, so you have 2 over 3. And the absolute value of 2 over 3, it's still 2 over 3. The absolute value of a positive number, it's always itself. And to see which fraction is bigger, we want to change them. We want to make them to have the same denominator. So 3 times 4 and 2 times 4. So that we have 8 over 12. Well, here we multiply by 3. So 4 times 3 and 3 times 3, and you will get 9 over 12. So in this case, they will have the same denominator, and you will see 9 over 12 is bigger than 8 over 12, which means the ramp would be steeper. The steeper it is, the more difficult it is to walk up. So it says, is it more difficult to walk up the ramp? So your answer would be yes, because it's steeper. That is question 20. And then let's see 21 to 24. I just did an example, so you should know how to do it. Let me just do one example with you. So let's see 21, I can pick any point. So my slope would be y2 minus y1, which is 18 minus 2, over x2 over x1, which would be 5 over 1. So I have 16 over 4, which is 4. So for the first one, my slope is 4. And then you'll do the rest of that, 22 through 24. Number 25, it says, it's still looking for the slope. So basically it's the same as question 20. So just see you have 2 points here, and then find the rise over run. And that's it. That's for question 25. Please finish all the problems through problem 25 and try to finish in class today. If you finish, please turn in to the subteacher.